Welcome to our 4 lecture electrophoresis. Uh, Myself, Professor Andy Pupati from Sudhakarnaik Institute of Pharmacy, Pusat. In this today's lecture, we are studying about the electrophoresis 4. Up till now, we are covering the 3 different lecture on electrophoresis. Uh, Out of which we have studied that we are using the paper for to the separation of the drugs. For by using the paper, we can separate the drug that we have studied. Then or migration of the drugs. Then we are using gel, agar gel for to the separation. But in even gel is also used in the case of this student lecture also. There is advanced technique in the case of that capillary, in which we added the gel. And in the third lecture, we are studying about the capillary electrophoresis, where we are using the capillary for the separation of the drug. So, in today's lecture, we are studying what is the capillary electrophoresis. In the syllabus, there is a technique of capillary electrophoresis. So we study each and everything like basic principle, then whatever the theory, instrumentation in short, then techniques or methods, and finally advantages. Then after the advantages, we study about the whatever the application of capillary electrophoresis, and finally we are studying about the whole applications of electrophoresis. So move toward the objective. In the case of objective, to study definition, principle, theory, instrumentation, technique of capillary electrophoresis, and understand application of electrophoresis. Okay. So in the case of definition of capillary electrophoresis, this kind of separation are facilitated by वो होते क्यों है फैसिलिटेटेड बाय द यूज़ ऑफ हाई वोल्टेज. हम यहाँ पे हाई वोल्टेज यूज़ करते हैं विच में जनरेट इलेक्ट्रो ऑस्मेटिक एंड इलेक्ट्रोफेरोटिक. That remember these two words, which may generated by electroosmotic and electrophoretic flow of buffer solution in ionic spaces. Okay, buffer solution and ionic spaces respectively within the capillary. लेकिन ये पूरी चीज़ें कैपिलरी के अंदर ही होने वाली है. So there is a separation facilitated by the use of high voltage. तो हम इसमें voltage high use कर रहे हैं. Generate electroosmotic and electrophoretic flow. That we are to study both point in theory, flow of buffer solutions and ionic spaces respectively within the capillary के अंदर. So move toward the principle. So in the case of principle, capillary electrophoresis is an analytical technique. ये तो हमें पता है कि analytical technique है. That separates ions. ये क्या करती है? आयन को सेपरेट करती है based on their electrophoretic mobility with the use of an applied voltage. Electrophoretic mobility with the use of an applied voltage. So the electrophoretic mobility is depend upon the change of the or whatever the charge of the molecule. Separate ion based electrophoretic mobility. अब ये जो वर्ड है electrophoretic mobility, हमने ऊपर जो दो वर्ड किए थे उसमें से electrophoretic आ गया, and that mobility movement with the use of an applied voltage. So voltage is useful for the separation of the components. Voltage generally more compared to the electrophoresis. So electrophoretic mobility is dependent upon the charge of the molecules. तो mobility किसके ऊपर depend है? Charge of the molecules, as well as the viscosity and the what is the radius that atoms covers. जो रेडियस है एटम कितना कवर कर रहा है इसके ऊपर भी ये डिपेंडेंट है. द रेट एट विच द पार्टिकल्स मूव्स इज डायरेक्टली प्रोपोर्शनल टू द अप्लाइड इलेक्ट्रिक फील्ड. जिस रेट से द रेट एट विच द पार्टिकल मूव्स, पार्टिकल मूव नहीं लगे हैं, डायरेक्टली प्रोपोर्शनल टू द अप्लाइड इलेक्ट्रिक फील्ड. दैट इज द ग्रेटर द फील्ड स्ट्रेंथ द फास्टर द मोबिलिटी एंड वाइस वर्सा. ओके, द रेट एट विच पार्टिकल मूव्स इज डायरेक्टली. अब ये पार्टिकल तो मूव रहे हैं, डिपेंड किसके ऊपर है? डायरेक्टली प्रोपोर्शनल टू द अप्लाइड इलेक्ट्रिक फील्ड. आप इलेक्ट्रिक फील्ड कितने अप्लाई कर रहे हैं उसके ऊपर डिपेंड है. सो द ग्रेटर द फील्ड स्ट्रेंथ द फास्टर इज द मोबिलिटी एंड वाइस वर्सा. मीन्स और अपोजिट हो जाएगा. अगर फील्ड स्ट्रेंथ कम होगी तो मोबिलिटी भी इसकी कम हो जाएगी. ओके, सो द न्यूट्रल स्पेसिस आर देयर. न्यूट्रल मीन चार्ज स्पेसिस वी कैन से आर नॉट अफेक्टेड. वो मोबिलिटी में उनकी अफेक्ट नहीं होगी. ओनली आयंस मूव्स with the electric field. Only जो ions रहते हैं which is having a particular charge, okay, so that get affected means electric field में affect होगे. If two ions are same size, आपके पास दो ions है same size के है, the one with greater charge, एक जो है उसके पास थोड़ा ज़्यादा चार्ज होगा, will move fastest, तो जल्दी से मूव होगा. While in the same case, if you are having ions of the same charge, आपके पास चार्ज सेम है, आयंस भी सेम है, लेकिन उनकी अगर साइज डिफरेंट हो गई, the smaller particles have less frictions and overall faster migration rate. Okay, उसमें का आयन जो है, ions of the same charge, smaller particles has less friction and overall faster migration rate. So the capillary electrophoresis is used most predominantly means before dominantly because it gives fastest result. हमें जो रिजल्ट मिलते हैं ये बहुत जल्दी मिलते हैं, फास्टेस्ट रिजल्ट, एंड प्रोवाइड हाई रेजोल्यूशन. हमें रेजोल्यूशन भी क्या होते हैं, बहुत ज़्यादा मिलते हैं, हाई रेजोल्यूशन सेपरेशन. इट इज़ यूजफुल टेक्निक बिकॉज देयर इज़ अ लार्ज रेंज ऑफ डिटेक्शन मेथड अवेलेबल. इट इज़ यूजफुल टेक्निक, ये टेक्निक बहुत यूजफुल है बिकॉज देयर इज़ अ लार्ज रेंज ऑफ डिटेक्शन मेथड अवेलेबल. इस केस में बहुत सारे डिटेक्शन मेथड अवेलेबल है, तो हमें बहुत सारे टेक्निक्स इसमें स्टडी कर सकते हैं. देन देयर इज़ अ थ्योरी. सो इन द केस ऑफ थ्योरी देयर इज़ एन इलेक्ट्रोफोरेटिक फ्लो. यहाँ पे क्या है, इलेक्ट्रोफोरेटिक फ्लो है. सो इन दिस केस इट इज़ अ प्रोसेस, इस प्रोसेस में in which sample ions moves under the influence of an applied voltage. यहाँ पे sample ion moves होते हैं under the influence of an applied voltage. The ions undergoes a force. Ions undergoes a force that is equal to the sample of electrophoretic mobility and the electric field strength. So ion undergoes a force that is equal to sample of the electrophoretic mobility. दोनों electrophoretic mobility equal होगा as well as the electric field strength. The flow of ion is towards the oppositely charged electrode. आयन का जो फ्लो होता है वो कहाँ पे होगा, towards the oppositely charged electrode. So UEP is equal to Q divided by 6n pi r and VEPF is equal to UEP into E. If you remember this formula, नियरली अबाउट इलेक्ट्रोफोरेटिक और इलेक्ट्रोऑस्मेटिक के दोनों भी सेम ही है. ओके, यहाँ पे चेक करना है आपको यूईपी, और यहाँ पे अगर जब यूईओएफ और ईपी आएगा. सो यूईपी इज इक्वल टू क्यू इंटू 6n बाई आर. सो यूईपी मीन्स व्हाट, इलेक्ट्रोफोरेटिक मोबिलिटी, मीन्स द मोबिलिटी, एंड ईपी इज इलेक्ट्रोफोरेटिक. क्यू मीन्स व्हाट एवर द चार्ज ऑन आयंस, आयन के ऊपर कौन सा चार्ज होगा. N means what, whatever the viscosity they are having. R means what, whatever the radius they covers. And is the electric field strength, is the electric field strength. Vp is the velocity, how much is the velocity to which they are travels. Electroosmotic flow. So osmosis under the influence of an electric field. Osmosis, electroosmotic flow में क्या है, osmosis is under the influence of electric field. The speed of electroosmotic flow can be adjusted. हम इसका flow adjust कर सकते हैं. Speed of the EOF can be adjusted by changing the buffer pH. हम pH का buffer change करके भी इसका adjust कर सकते हैं. Bulk movement of solute is caused by EOF. Bulk mean बहुत सारे ग्रुप में. Bulk movement of solute is caused by electroosmotic flow. EOF is usually sufficient to swap all positive, neutral as well as negative species toward the same end. एक ही जगह पे, एक ही साइड पे लाने के लिए इस इलेक्ट्रोऑस्मोटिक फ्लो का काम करता है. यूजुअली sufficient to save all positive, neutral and negative species toward the same end. So mu is the velocity, we know that mobility. EOF is the electroosmotic flow is equal to C into Z divided by 4n pi. So VEOF is equal to mu EOF into E. So UEOF is the electroosmotic flow, C is the dielectric constant, is the electric field constant. Okay, in the round note there is an E, electric field constant or electric strength. Z is zeta potential in the first upper equation, then the N is the viscosity, and VEOF is the velocity, downward side. So the velocity of the ion is the sum of velocity of ions means what? Sum means addition of velocity of EOF, electroosmotic flow, and electro whatever the electrophoretic flow, EPF, is equal to V is total is equal to EOF plus VOF. Okay, so that thing is the nothing but the theoretically. Then instrumentation. So a typical capillary electrophoresis system consists of, we are using buffer solutions, then we are applying the voltage, then there is a sample introduction system into this one, third component, and whatever the capillary is there, how its internal diameter, all things we have to be study, and then the by the use of detector we are separating or analyzing the components. Okay, and then there is an output device. So some instrument include a temperature control device. कुछ इंस्ट्रूमेंट में क्या होता है, दे आर यूजिंग द टेम्परेचर, इंक्लूड द टेम्परेचर कंट्रोल डिवाइस टू इंश्योर द रिप्रोड्यूसिबल रिजल्ट. अगर हमें रिजल्ट कंटिन्यूसली चाहिए, रिप्रोड्यूसिबल चाहिए, तो हम क्या करेंगे, वी इंक्लूड द टेम्परेचर कंट्रोल डिवाइस. दिस इज बिकॉज द सेपरेशन ऑफ द सैंपल डिपेंड्स अपॉन द इलेक्ट्रोफोरेटिक मोबिलिटी. बिकॉज सेपरेशन किसके ऊपर डिपेंड है, इलेक्ट्रोफोरेटिक मोबिलिटी, एंड द वेलोसिटी और द विस्कोसिटी ऑफ द सॉल्यूशन डिक्रीज एज द कॉलम टेम्परेचर राइजेस. जैसे उनका टेम्परेचर कॉलम का बढ़ेगा, viscosity इनकी डिक्रीज होने लगेगी, which is helpful. Okay, so now what is the amount of sample is required is 5 to 30 micrometer cube. Okay, so introduction into the capillary with the appropriate buffer at the introduction to the capillary with the appropriate buffer at the anode end. एक चीज़ याद रखना है कि हमें एनोड एंड से इसको पास करना है सैंपल को. ठीक है, सो देयर इज एन एप्लीकेशन, सैंपल एप्लीकेशन इज डन बाय अदर by one method. कौन सी भी एक मेथड हम चूज कर सकते हैं, by using voltage injection or by the pressure injection. Voltage injection means what, the buffer reservoir is replaced by the sample reservoir. तो हम बफर रिजर्वायर को था उसको निकाल लेंगे, उसके जगह पे उसी जगह पे हम क्या करेंगे, सैंपल रिजर्वायर रख देंगे. द हाई वोल्टेज इज अप्लाइड, उसके बाद हम वोल्टेज बढ़ा देंगे. द पॉजिटिव इलेक्ट्रोड बफर रिजर्वायर इज प्लेस्ड, मीन्स एनोड इज बफर रिजर्वायर इज प्लेस्ड again, and voltage is applied for the separation. Okay, so we are reservoir of high voltage is applied, so positive buffer reservoir is placed again. हमने जैसे उसके बाद सैंपल ले लिया, बफर रिजर्वायर हमने फिर से सेट कर लिया, एंड वोल्टेज अप्लाइड फॉर द सेपरेशन. बाद में वोल्टेज हम अप्लाई करेंगे. Anodic end of the capillary, again in the same pressure injection baby, anodic end of the capillary is removed. हम उसको रिमूव कर लेंगे फ्रॉम बफर एंड प्लेस इन द एयर टाइट सैंपल सोल्यूशन. बाद में हम क्या करेंगे, इसको प्लेस करेंगे एयर टाइट सैंपल सोल्यूशन विथ प्रेशर simple, or the pressure sample is placed into the capillary, kept back in the buffer sample, and voltage is applied. Okay, so now there is an capillary. How capillary is there, internal diameter is there. ID is internal diameter, that is 50 micrometer, external diameter 300 micrometer. Then length 50 to 100 centimeter is its length. Fused silica as well as the capillary tube. So polyimide coating externally we can done, and packed with the buffer is used. Buffer pack जल्दी से हम इसका यूज करते हैं. Then whatever the amount of voltage that we are applying the high voltage, but the range is from nearly about 5 to 50 kilovolts. So the compound migrates at different rate. Compound क्या होता है, migrate at different rate along the length. Okay, एक particular length के साथ ट्रैवल होने लगता है. Although separated by the electrophoretic migration. Although क्या होता है इनका, separated by the electrophoretic migration. All the sample is drawn towards the cathode by electroendosmosis. All the sample is drawn towards the cathode by electroendosmosis. Since this flow is strong, the rate of electrophoretic flow is greater than the electrophoretic velocity of the analyte ions. Since this flow is strong, the rate of electrophoretic flow is greater than the electrophoretic velocity of the analyte ions. Okay, then these are about the whatever the things are there, how done, how the injection is there, everything is done. Then the sample is going to be run, the migration is going to be takes place, and then from anode to cathode there is a movement takes place, and then finally it is toward detector. So the detector is a capillary electrophoresis is लेज़र इंड्यूस्ड फ्लोरेसेंस. हम लेज़र इंड्यूस करके फ्लोरेसेंस प्रोड्यूस करेंगे. इट इज़ एन वेरी पॉपुलर कैपिलरी इलेक्ट्रोफोरेसिस डिटेक्टर that have 0.01 attomole sensitivity for fluorescence molecule. Example is derived protein. So direct observance visible can be used for organics. अगर आपके पास ऑर्गेनिक कंपाउंड उनके स्टडी के लिए हम क्या यूज़ करते हैं, डायरेक्ट ऑब्जर्वेंस. फॉर इनऑर्गेनिक्स इनडायरेक्ट ऑब्जर्वेंस मेथड आर यूज्ड. फॉर इनऑर्गेनिक कंपोनेंट से तो इनडायरेक्ट ऑब्जर्वेंस मेथड आर यूज्ड. इंस्टेड ऑफ ऑब्जर्वेशन observative buffer we use the chromate is displaced by analytical analytines. Detection limit are in the 50 to 500 ppb range. The alternate methods involves potentiometric and conductometric detection are also used. Potentiometric detection, conductometric detection can be used for to the identification. So these are the kind of detector that we are using. Then modes of capillary electrophoresis. Which kind of capillary electrophoresis are there? How they are capillary electrophoresis takes place. That is another point in the case of this one. So capillary zone electrophoresis (CZE). So capillary zone electrophoresis, also known as free solution capillary electrophoresis, okay, FECS, is the simplest form of capillary electrophoresis. ये जो है ना, ये simplest form of capillary electrophoresis है. What we have been talking about is the separation. The simplest what we are talking is that the separation mechanism is based on the difference in the charge. Okay, separation mechanism है based on the difference in the charge and ionic radius of the analytes. How much radius they covers, ionic radius of the analyte. Okay, fundamental capillary electrophoresis are homogeneity to the buffer. ये homogeneous buffer के साथ solution and constant field strength throughout the length of the capillary. इसमें क्या है, constant field strength is remain the constant. Okay, constant field strength throughout the length of the capillary. Field strength हम थोड़ा भी चेंज नहीं करने वाले इस चीज़ में, ठीक है. Then the capillary gel electrophoresis. So in the case of capillary gel electrophoresis, CGE बोलते हैं उसको, it is an independent adaptation of the traditional gel electrophoresis. Simplest है, जेल इसके अंदर हम इंक्लूड कर लेते हैं. यहाँ पे अगर हम बफर हो गया, यहाँ पे हमारा बफर है और इसके अंदर हमने जेल अप्लाई कर लिए. So capillary gel electrophoresis is high voltage अप्लाई करते. So capillary gel electrophoresis is the adaptation of the traditional gel electrophoresis into the capillary. CGE used for separation based on the difference in the solute size as a particle migrate through the gel. CGE separation based on the difference in the solute size. Solute size different होगी तो उसके ऊपर हम इसका separation कर सकते हैं. So particle migrate through the gel. So gel prevent the capillary walls. Gel क्या करेंगे? Prevent the capillary walls from absorbing then solute. Okay, so this technique is commonly employed in chain molecular weight analysis of proteins and in application of DNA sequencing and genotyping. वहाँ पे इसका यूज़ किया जाता है. Then capillary isotachophoresis. So isotachophoresis, CITP. Capillary isotachophoresis is a focusing technique based on the migration of samples component between leading एंड टर्मिनेटिंग इलेक्ट्रोलाइट्स. अगर आप ये डायग्राम अगर आप देख पा रहे हो तो यहाँ पे ग्रुप्स है, तो यहाँ पे ब्लू रेड ग्रीन सभी है, तो यहाँ पे ब्लू सेपरेट हो रहा है, बाद में ग्रीन, बाद में रेड. सो हियर इज वाज देयर इज अ सैम्पल कंपोनेंट्स बिटवीन लीडिंग एंड टर्मिनेटिंग इलेक्ट्रोलाइट्स. शुरुआत और एंड में सेपरेशन करते हैं. आइसोटैक में सेम स्पीड, ठीक है. व्हाट आर सॉलिड्स हैविंग मोबिलिटी इंटरमीडिएट टू दोज ऑफ द लीडिंग एंड टर्मिनेशन इलेक्ट्रोलाइट्स स्टेक इनटू द शार्प फोकसिंग जोन. Okay, although it is used as a mode of separation, transient ITP has been used primarily as a simple concentration technique. Although it is used as a mode of separation, transient ITP has been used primarily as a sample concentration technique. Okay, then finally there is a capillary isoelectric focusing. Capillary isoelectric focusing, CIEF, capillary isoelectric focusing allows amphoteric molecules such as proteins to be separated by electrophoresis in a pH gradient generated between the cathode and anode. CIF is allows amphoteric molecules such as protein to be separated by electrophoresis in a pH gradient generated between the cathode and anode. A solute will migrate to a point. इसमें क्या होता है? Solute will migrate to a point where its net charge is 0. इसमें इसका net charge 0 होगा. At the solute isoelectric point, that is PL, migration stop and the sample is focused into a tight zone. कहाँ पे focus होता है? Into a tight zone. In CIEF, once solute has focused, when in CIF, once a solute has focused at its whatever the isoelectric point PL जो होते हैं, the zone is mobilized and pass the detector. Once the solute is focused, क्योंकि हम इसमें क्या कर रहे हैं? The solute migrates at the point where its net charge is 0, and at the solute isoelectric point, migration stops and the sample is focused into the tight zone. So in CIEF, once the solute has focused and its PL, okay, say isoelectric point, the zone is mobilized past the detector. ये detector को pass कर जाता है. यहाँ पे अगर आप देख पा रहे हो तो ये detector है, इसको pass कर जाएगा. ठीक है, by either pressure or chemical means. This technique is commonly employed in protein castration as a mechanism to determine the protein isoelectric point. So that is the fourth of isoelectric means isoelectric focusing. Then we study about the advantages and disadvantages. What are the advantages are there? Offer a new selectivity and alternative to HPLs. HPLs को क्या है? Alternative है. Easy and predictable and selective. Easy है, predictable है और selective भी है. High separation efficiency, millions of theoretical plates. इसकी separation efficiency बहुत ज़्यादा है because it is having a millions of theoretical plates. Then small sample required. 1 to 10 nanoliter sample we are required for separation. Faster separation because it requires 1 to 50 or 45 minutes for the separation. It can be automated. If you say the automatic thing is easily coupled to mass spectroscopy, मास स्पेक्ट्रोस्कोपी सब इजीली कपल किया जाता है और डिफरेंट मोड से इसके अंदर. डिसएडवांटेजेस क्या है? कैन नॉट डू प्रिवेंट स्केल ऑपरेशन सेपरेशन. लार्ज स्केल में कैन नॉट डू प्रिवेंट स्केल सेपरेशन. लार्ज कॉन्सेंट्रेशन और लो कॉन्सेंट्रेशन एंड लार्ज वॉल्यूम इज डिफिकल्ट. एप्लीकेशन ऑफ कॉपलर इलेक्ट्रोफोरेसिस एन अल्टरनेटिव फॉर डीएनए एनालिसिस. डीएनए एनालिसिस के लिए यूज किया जाता है herpes simplex virus DNA in CSF, okay, for diagnosis infantilitis. Gene rearrangement corrective with the lymphoproliferative disorders, polymorphism in genes, then tetranucleotide associated with the an alternative for the DNA analysis. Herpes simplex virus DNA is in CSF for diagnosis. Gene rearrangement correlation with the lymphoproliferative disorders we have discussed. The polymorphism in gene, tetranucleotide associated with the hypercholesterolemia, diagnosis fragile X syndromes in the muscular dystrophy, and so many applications of the even in the PCR product studies also there where we are using the capillary electrophoresis. Finally, we are studying about the applications of electrophoresis. So the main use as we are DNA fingerprinting, PCR technique we are saying. So forensic science, in the case of forensic science, DNA fingerprinting, using of the DNA fingerprinting for the criminals means each and every criminal is having the same fingerprinting. So because that identical fingerprinting, we can analysis that criminals. So that is done by this electrophoresis technique. Molecular biology to separate and organize DNA, RNA by size. So molecular biology के अंदर भी हम to separate and organize DNA and RNA. In the case of genetic, provide nuclear or provide the clear pictures of the DNA. So in the case of genetic, we get the clear structure or clear pictures help to prepare DNA for cloning and genetic engineering. So there is a vast because each and every there is an special chapters are there like genetic engineering, gene cloning, and so many. These are the biotechnology parts. In the case of microbiology, information about the organisms. In the case of virology, to help diagnosis different strains in virus or of virus. In the case of biochemistry, mapping of cellular components, particular proteins and nucleic acids. In case of protein and peptide determinations, to check purity, physical properties like melting, molecular weights, ionic strength PL, binding studies, identifications in the capillary electrophoresis mass spectroscopy. In the quantitations, we identify the quantities on the basis of the migrations. Amino acids, various acids are there that can be studied. Then we can also use it in the case of determination of additives in the food and drugs, for the separation of the tetrazymes, sunset aloes, amarnath, indigos, carmines. So many things are there. We can study separation and quantification of the vitamins in fruits and vegetables. For the separation and quantification of ascorbic acid in vegetables and fruits can be studied. Separation of enantiomers from the racemic mixture. Okay, so how we done with the racemic mixture separation in the electrophoregram of 1% enantiomer in presence of an enantiomeric fluorox hand. Separation condition is 57 centimeter by 50 micrometer. That is an electrolyte that we are using. We are also using the borax 10 mm price, 150 mm beta cyclooctane, 6 molar urea isopropanol, 80-20% weight by volume, adjusted to pH 2.5 with the astropurity, that is a phosphoric acid. We are also using glacial acetic acid also, therefore maintaining the acidity. Temperature is for 25 degrees Celsius, and detection, okay, uh, detection, that is 15 kilovolts, reproducible with the permission from the area. Okay, so that things is separation and sugar from racemic mixture. Then determination of minerals, fatty acids, and the carbohydrates that can be done, and determination of various organic acid like eperic acid, oxalic acid, tartaric acid, malic acid, lactic acid in the foods. So various acids in the food content can be studied, and also used in the case of pharmaceutical acids. So in the case of this diagram, you can able to see that there is number of the mixture can be analysis, and each and every one can be separated. So these are the whole application of the electrophoresis. So I hope you are understanding with this concept. So thank you so much for patience listening of this lecture. Stay happy, stay safe in your home. Thank you very much.